In space weather attacks, the effects on a planet's upper atmosphere can be as beautiful as a display of aurora borealis, or it can cause dangerous disruptions of communication systems and power grids, and even pose a threat to astronauts working in near-Earth space. Scientists at MIT's Haystack Observatory work to measure the effects on our planet as the sun stirs up a little space weather. So what happens to a planet during a space weather attack? Let's take Earth as an example. It moves through space protected by a thick atmosphere and the magnetosphere, which is a region around the planet that is influenced by our magnetic field. The two are very tightly coupled together. The magnetic field extends out about 65,000 kilometers from Earth's surface on the side facing the sun. When a solar outburst rams into our magnetosphere, plasma is guided along magnetic field lines to places where it collides with molecules of gas in our upper atmosphere. Solar ultraviolet radiation and X-rays also interact each day with the gases at the top of our atmosphere to create the ionosphere. The ionosphere allows radio signals to travel from place to place around the planet, a process known as propagation. Any changes in the ionosphere due to a solar outburst will also affect the propagation of radio waves, disrupting or shutting down radio communications. When a storm bursts out from the sun, the first thing to hit Earth's ionosphere is a blizzard of energetic particles. These particles are a danger to spacecraft and astronauts. Without the protective blanket of our atmosphere and magnetic field, life on Earth would also suffer serious effects from exposure to this strong solar radiation. One of the consequences of a solar outburst is the appearance of huge circulating currents about 100 kilometers up in our atmosphere. The magnetic fields from those electric currents can overload power grids and shut them down. Understanding how Earth's magnetosphere and ionosphere interact with the solar wind, especially during outbursts, is a big step forward in learning how to protect ourselves from the effects of space weather.